It's the 21st show. I'm Brian Mackey. The FIFA World Cup is underway. And I don't know if you've noticed some of the crazy technology we're seeing this year. There's that offsides detection using the help of AI and those body cams the referees are wearing. Well, there's another piece of technology you'll see on the field, but maybe not where you would think. You have to look at the cleats or boots being worn by the players of England, Germany, and Spain. That's because their shoes feature a polymer material that better adapts to their movements. It's a technology that was developed at the University of Illinois, Urbana-Champaign. Joining us now to talk more about this is Dr. Bill King, a professor in engineering at UIUC. Bill, welcome to the 21st show.
Hi, Brian. Great to talk to you.
So I should say, listeners, in order to make schedules work today, we taped this conversation earlier today, so no calls for the rest of the show. But you can always let us know what you thought. Our email address is talk@21stshow.org. All right, maybe we can just start with where this polymer material, where the idea for this came about.
Yeah, thanks, Brian. We've been working in my research lab at the university for around 20 years on this technology. So we started in the mid 2000s, and we were working on how to manufacture small structures into polymers. And we were doing that for applications in semiconductors and electronics, where people want to make small structures. That's how the electronics get made. And we realized that what we were working on was scalable to other kinds of applications. So we realized we could make things that were bigger and in different kinds of materials, far beyond the semiconductor idea. And we started publishing those ideas, and folks from industry came to us and said they had ideas for where this could go. And that's really how it started. People contacted us about all kinds of things they wanted to do with these small polymer structures, and that includes shoes.
So maybe this is where I sometimes say, explain this to me like I'm a smart 13-year-old. What exactly is this polymer material?
So what we are able to do is manufacture small mechanical structures like miniature pillars into the surface of the polymer that goes in the shoe. And what that does is these small pillars create a kind of a roughness in the shoe that changes the friction properties. It changes how the surface of the shoe interacts with the soccer ball. So when the player dribbles the ball, the the pillars give the player a light touch and a nimbleness to be able to move the ball around quickly. But when the player strikes the ball with force, perhaps for a shot on goal or a long pass, it gives the player an enhanced grip. So those microstructures on the surface of the shoe grab the ball and allow the player to have greater force and greater control over what the ball does. So these shoes kind of switch back and forth. When you're dribbling lightly, you get one kind of performance, and when you strike the ball, you get another kind of performance.
Is that something you can actually feel with your hand? Like if I were to take the shoe and gently rub it versus, whack it with my fist closed or something like that?
Yes, absolutely you can. And in fact, these shoes are the technology is in these shoes. They're for sale everywhere. I'm not trying to give an advertisement here, but they're on the shelf in the store. And if you see them there, give them a rub and see for yourself.
This is the Predator line of Adidas, maybe one that we're talking about.
That's right.
Yeah. So, and what is actually, is it something you can see when this is happening, right? Or do you need like a microscope or even, something more powerful than that?
It helps if you have a microscope.
Yeah.
But if you have some good vision or corrected vision, like some of us, then yeah, you can barely see it with your eye.
Barely see it with your eye. Okay, so we mentioned the Adidas Predator line of cleats. What was it like working with this company, as well as some of the soccer players, to develop these shoes?
So I'll go back to our origin story for the technology. So we had many companies coming to us interested in the technology, and so we started a company out of my laboratory at the university. The name of that company is Huwaki. And so that company is 18 years old, and it's been working with companies like Adidas and other companies, for this entire time. So over the years, we've actually developed thousands of different kinds of microstructure surfaces for all kinds of different applications. Shoes, gloves, helmets. The technology is also used for surgical devices that get implanted in the body, where the microstructures give grip for those surgical devices and implanted devices. The technology is also used in certain kinds of construction products. So the applications are very diverse. Every time there's a new application that comes to the company, we have this library and we have these engineering design principles that we can bring to bear. So the technology can be used for lots of different things.
Did you actually work with soccer players or interview them or something like that, or have them in the lab, or what is that process like?
The shoe company actually had a particular idea in mind for what they wanted to accomplish, and that was based on their experience. So this particular brand of shoes has been around for a long time, decades, and it's always been a ball control shoe. And so the players that wear these shoes are the players that are known for ball control. And so the shoe company, had that specifically in mind. They wanted to achieve the next level of ball control for this technology.
So I guess initially one of the concerns with this tech is that it might not scale enough to where it could be manufactured for consumer products. So tell me about that and how you work through, that engineering challenge.
That's a great question. When we started working on the technology, the this kind of microstructure manufacturing was thought to be able to scale to just a few inches in size, and no further. And so one of our key ideas was that we would be able to make significant quantities of these polymer films. Um, and so the technology that part of the technology that we developed was the ability to go from inches to feet to 10 feet and larger. So the way that works is we make small pieces at the several inch scale, but then we make replicates. And so actually at the core of the technology is the replication, where we make something small and then we multiply it and then we multiply it again and multiply it again. So one of the very first customers that we had for this technology was a company that makes tires for cars and airplanes and farm equipment. And they wanted to put these microstructures on their tires. And we actually went to their factory and showed that we could put these microstructures on tires in a real manufacturing production environment. And there, we were making, thousands of square feet a day.
This is interesting. This idea of this, for a long time. Science, coming out of the academy, being used in production. You mentioned that you have a company. I know this is now quite common, I gather, for different engineering faculty, especially, but also other disciplines as well. Can you talk about that evolution in higher education to, maybe keep people who might have been poached to go work at Bell Labs a generation or two ago to now stay within the university, but also be able to pursue these, separate separate work with industry.
Yeah, absolutely. For the university to be doing things that really matter, we need to have our ideas that get out into the world and affect regular folks. And one of the ways that we can do that is by working with industry, either by starting companies or collaborating with big companies or finding other ways to get our technology into the hands of practitioners. And so we can do that through inventions that come out of the university, through startups. There's lots of ways that happens, but I would say over my career, the university has really focused on, finding better and improved ways to get our ideas and our technology out into the world that actually, impacts regular people's lives.
So, okay, we've talked about the shoes, we've talked about the tires. Say more about the medical use. You mentioned that this is something that can be used in what, surgical applications? How does that work?
Absolutely. So, before the shoes, the medical applications were probably the biggest customer set for this technology. So right now, the microstructure technology is being used in fabrics that go into surgery for patients that are treated for colon cancer. And so the polymer fabric film is used to help stitch together your colon during and after surgery. And so those devices are actually left inside your body after the surgery, and it promotes healing. So that technology is used in surgeries being conducted in Europe right now. There are hundreds of human patients that have those microstructures inside of them right now. There's cancer survivors, and the technology is currently under review for approval by the FDA in the United States. And hopefully that will occur in the next year or so.
How do you think about the frontiers of your field, right? I mean, is this, when you take yourself back to working on this a couple of decades ago, um, is it a problem that you were trying to solve, or were you just playing around with these ideas and this is something that came out of it? You know what? I'm interested in the sort of eureka moment of it all.
That's a great question. So, part of my research philosophy is that the science makes the engineering better, and the engineering makes the science better. So, I'm always looking for interesting problems and opportunities that has some combination of real science principles and the opportunity for new creative ideas and innovation, but marry that up with real problems in the world. By focusing on real problems, you can talk to real people that are working on their own solutions and challenges, and that can give you inspiration and focus on how to proceed.
I just try to imagine though, somebody sitting around with a notebook saying like, "All right, what can we do that's going to be useful in colon cancer surgery and the World Cup?" you know. Uh, so where do you see this technology further developing potentially?
Well, I'll say that neither of those things were in my notebook. But for sure, we were like, this is amazing. People, if we get this out into the world, we're going to meet some people who are interested in turning it into stuff. And fortunately, that is what happened in this case.
So, big picture, do you see and we're in this moment where technology is everywhere. There's a lot of talk about artificial intelligence, or what we're calling artificial intelligence these days, these large language models. Um, there's this idea of then at the same time of like more natural products, right? Talk about this. How do you think about that sort of big picture divide between synthetic materials and what they provide for us versus, the old ways, something more traditional, more natural, you might say.
Hmm. Well, for sure, AI is changing the way that engineers do their work and will have a big change in the future on how engineers do their work.
How so?
Um, Well, so that's a great question, and I'll tell you that the field of engineering is working very hard to figure this out, and things are changing on almost a daily basis with new ideas and so on. Um, but the way that we organize and search information, the way that we analyze data, the way that we develop new software, all those things are really dramatically changing. The other thing that's happening is that all of these kind of gee whiz technologies that the computer scientists have come up with for AI, they are pretty rapidly flowing into other domains of engineering, like mechanical engineering and material science. And so what we're going to see over the next decade is, I think, a new wave of innovation in product design and materials and things of that nature that really benefited from the AI.
You're not talking here about like Claude or ChatGPT or the things that, everyday people think of as AI, right? I mean, or are you talking about something more boutique, Yeah.
Both. So actually, the large language models are super interesting. But what is happening is engineers are figuring out how to adopt those models for more specific engineering tasks. So you can take a Claude or a ChatGPT, and you can start to talk to it about materials design or mechanical engineering principles, and it can learn those ideas and be helpful in developing new products.
Dr. Bill King is a professor in engineering at the University of Illinois Urbana-Champaign. Thanks so much for being with us today. Appreciate your time.
Hey, thanks so much, Brian.
Once again, you can see this technology on Adidas or Adidas Predator cleats. I know for sure they're being used by players from England, Germany, and Spain. That's it for us today. Tomorrow on the 21st show, we'll speak with Lois Romano, a longtime journalist at the Washington Post and Politico, who has written a book on Mary Lincoln. It's called An Inconvenient Widow: The Torment, Trial, and Triumph of Mary Todd Lincoln. That's coming up tomorrow on the 21st show. The 21st show is a production of Illinois Public Media. I'm Brian Mackey. Thanks for listening. We'll talk with you again tomorrow.